Welcome. My name is Aileen Gemma Smith, and I'm Head of Developer Relations for Americas and for Online at AWS. I'm so excited for this series of AWS On Air. Today, I'm pleased to welcome Roshan Shah, who is the VP of CSC Operations, whose primary focus is on AI to the manufacturing sector from Georgia Pacific. Roshan, welcome.
Thank you, Aileen. Nice to be here.
Yeah. So can you tell us a little bit more about your role and a little bit more for folks that are tuning in about Georgia Pacific?
Sure. So, Georgia Pacific, one of the largest paper company based out of Atlanta, Georgia, part of Koch Industries. We operate about 150 manufacturing facilities, primarily across three segments. Um, of course, tissue, towel, napkin, things that we all use in our daily lives. Then there's the building products segment, where when when you buy a house and has plywood and OSB and drywall and lumber, of course, that's the second segment. And then there's the third, which is more of the cellulose, corrugated, and packaging segment. So that's kind of the combination of the three business segments that make up Georgia Pacific. And as I mentioned, across 150 manufacturing facilities across North America. My role, I'm part of operations where I lead what we call CSC operations, Collaboration Support Center. Our primary objective there is about 75 engineers and data scientists that come together to build a lot of to integrate a lot of artificial intelligence within our manufacturing operations, such that we can make more database decisions, rely more on artificial intelligence, and not so much as move away, but really augment our operations such that we can see things coming, right? Whether that be an asset failure, or a process failure, or a safety event, if you will.
Yeah.
Um, we look at all that data in real time to be able to get ahead of those. They get ahead of those things, and my team and my we're fortunate. We work for a co-company where we have the ability to spend our days looking at all that data and get ahead of those failures. So that's
Yeah.
kind of our responsibility.
And I understand that you're a mathematician, is that right?
Yes, I'm cursed by being a statistician, mathematician, however you want to think about it. I did double major in undergrad, so uh, at times numbers are easier than words for me, but
Okay.
that's just, I guess as you could say, I'm cursed by being a statistician.
No, I actually it's a privilege. I want to kind of lean more into the collaboration and support center because for folks that are tuning in, give us a vision of how did that get started and what was the impetus behind putting together this collaboration and support center at Georgia Pacific?
Sure. So, as you think about what's occurred in the last 10 to 15 years within the manufacturing segment, much of the subject matter expertise, right, that has exited the industry via retirement or other things. And more and more folks don't, it's harder to recruit talent within our manufacturing facilities that tend to be in remote areas.
Yeah.
So as we've come, as we think about all that, it's become even more important for us to rely on data and systems, and
Mhm.
that's where maybe I'm fortunate in the sense that I'm in an area where we can leverage data, math, stats, to be able to augment really our remainder or whatever manufacturing staff that we do have, which is, again, we're very proud to have many of our colleagues serving in that capacity. And it became very important for us to be able to retain that knowledge, and the best
Yeah.
way for us to do that, particularly in the cloud environment, and we use quite a bit of AWS products. So it became easier and really important for us to be able to put all that data in the cloud and be able to run math and stats and computer programs against it to be able to help make better decisions, or help make it such that our folks in the field are really
Yeah.
able to focus on running their operations on a day-to-day basis, as opposed to always be thinking, hey, what's going to break, and how do I really avoid unplanned events, so to speak. So that's where, a couple of years ago, our leadership challenged us with, could we think about transforming operations by leveraging, more data, more math, and that's where it started.
Yeah, and I from a December 2019 press release, I note that you were using AWS that helped to improve selected plant process productivity by over 30% and helped to predict when equipment might fail with a 60 to 90-day lead time, which is actually transformational for what folks are doing in the field to have that lead time and to get in front of it.
Absolutely, and I think we keep we're fortunate again. A lot of mistakes for us, and a lot of lessons learned from that, all
Yeah,
positive manner. But I think we keep pushing the boundaries for ourselves in the sense that, could we get better at predicting failures? And again,
yeah,
failures have an impact on not just our operations, but the safety, right? So how do
of
we
course.
get ahead of that? That's always a question for us. And in the last year, I think we've made further strides on that. Like, as an example, right? I think you said it, 60 to 90 days. We tend to stay ahead of processes. I think we've just
Right.
continued to trend that toward closer to 90 days. We're not perfectly there.
Yep.
Sometimes we do even more than 90 days, and sometimes we do 6 hours, and that's just kind of nature of equipment failure. But we keep pushing the boundary, and just as a data point, I think
Yeah.
towards end of 2019, on a nightly basis, we used to process anywhere from 300 to 400 billion records of data to be able to create these predictions.
Mm.
Today, we do closer to 700 billion on a nightly basis. Uh,
700 let me just put a finer exclamation point on that. 700 billion on a nightly basis.
700 billion records of data on a nightly basis. And honestly, about 4 years ago, we used to look
Yeah.
at about 100,000 records. So, we've exponentially grown the volume of data. But just because you process more data doesn't necessarily mean that makes it to the bottom line, right? Where I
Right.
think where it has really a lot of impact is, well, two things. First, we've seen a lot of value to the bottom line, really.
Yeah.
Um, we can see our unplanned events go down quite dramatically. We've also seen a tremendous amount of reductions in really significant failures. So if you look at
Mhm.
the count of significant failures, mostly on
Mhm.
process or asset-wise, uh,
Yeah.
even last year to compare to where we are, we've seen quite a bit of reductions. We still have a lot of room to improve upon, but it's been quite fortunate, and to be part of the team that works on that. The second thing is, again, just as a point of comparison, last year, when we processed as many records as we did, we produced predictions, right, that would tell us that, hey, you're likely to incur this, and our false positive rates used to be relatively high, and that's okay. We walked into it knowing that, um, just because we had to start somewhere. But I think our false positives are much lower today than where we were, much
Mhm.
lower, a factor of a few. Um, and just as a data point, today we produce about 178 million predictions per day, right? Just across all those data points that we talked about, all these IoT sensors that they're pretty
Right.
old, but we do the best we can, and there's again a lot of room to improve, of course.
Yeah, but you've seen improvements not only in productivity, but also in reduced waste, right? I remember looking at a previous talk where they were saying how you were actually able to use the data to now say, well, what's the speed that we need to do of these reels such that the paper won't break? Because when we know that, that actually is also a significant cost savings and process improvement for us. And when you think about it across disparate systems and all of this is not coming in the same way or has the same constraints, it's really quite transformational.
Absolutely, and that since then we've actually expanded that type of effort into quite a few other areas. So one
Hmm.
example I can offer you is, if you think about a manufacturing process that might have 10 different steps,
Yeah.
we've been able to not just figure out, hey, what step do I need to improve upon so I have the most optimal outcome over here? We've gone from thinking about just that in a isolated event to thinking about that in an entire continuous process. So what we can do, and it's, again, we're still learning through it, so it's not perfect. I don't want to give that impression, right? But
Yeah.
we've made it pretty good strides into being able to look at the entire 10-step process almost in real time and
Mhm.
to tell you that, hey, step number three, there was a manufacturing defect, right? And we need to do X, Y, Z in step four, and then A, B, C in step six, such that when we get the output at step nine, where we measure quality, we're at the most optimal way that we can be. So again, to differentiate that from what how we used to think is, let's just
Yeah.
optimize this in individual piece because that was the more important one. But
Right.
now thinking, holistically, how do we optimize that entire piece so we get the best possible outcome while adjusting for it along the way, almost in real time. That's been pretty transformative, and 2021 for us is going to be a lot more of that type of work. And there's artificial intelligence across the board. We also
Yeah.
have a lot of optimization engines, and it's been quite rewarding. I joked about being cursed by being a mathematician, but
Mhm.
it's a lot of fun to just kind of sit there and be able to articulate and be able to see that these very complex math formulas applied against things that you can measure at the end and you can touch and feel it, and it's quite rewarding.
Absolutely, absolutely. And I think part of that also speaks to something that we had touched on earlier, which is that cross team collaboration that you've really truly built as almost the fabric of what you do through the collaboration and support center. Because bringing together those subject matter experts that have a deep understanding and come to it with a different lens than folks that are looking at it from a data science point of view or from a stats point of view, I think it's just some interesting symmetry. So, for folks that are watching, can you give us more about lessons learned and opportunities that you saw through the Collaboration and Support Center?
Sure. Probably the first one that I might say is we all hear about artificial intelligence and machine learning and AI ML, just about every other word coming out of everybody's mouth these days, right? What we learned is all of that is doable, absolutely, but we have to walk into it with some expectation that we're going to make some mistakes, and
Mm.
that's just the reality of it. And it's a little like R&D. You never
Yeah.
get the very first thing that you apply to be perfect, but what that does is it teaches you things. We joke about. Um, so I'll give you one example.
Go
We
for it.
we have, the very first model we put in production was version 6.5, which means we built everything from version zero point 0.1 to 6.4 and realized it was no good. And 6.5 today, we get a lot of value out of, but we're running version 14. So all that's taught us is that you have to be able to accept that you're going to make some mistakes. And, just because you apply a pandas library doesn't necessarily mean you're going to get the best output. That's where having a subject matter expert sitting right next to you is really
Yeah.
important. So at CSC Collaboration Support Center, one of the key principles is that we always pair
Mhm.
a subject matter expert or an engineer with a data scientist, because the goal is to be able to build solution that someone can do something with, right?
Yeah.
Um, and more often than not, and this was a mistake I've certainly made a lot in my career, is that we tend to think, let me go get some data scientists, we'll hand them the data, they'll come out with this golden tablet, and that will be the end of it. And that's
Mhm.
almost 99% of the time, that's never the case. That's where, you put a problem in front of an engineer and let them work with a data scientist where they pull on each other's comparative advantage.
Yeah.
I think that's where we found the best success is an engineer starts with a problem, asks a data scientist that says, hey, here's what I'm trying to accomplish,
Right.
while remaining open to the idea that you might get a solution that is not what you expected, might be far better, might be far worse, but you have to be able to be open to that.
Yeah.
And then that feedback loop. So the data scientist comes back with, hey, here's what I learned. But if an engineer says, yeah, but I can't do anything with it, or that correlation doesn't make sense,
Right.
that's where that feedback, that back and forth makes a lot of sense. And the fact that they're sitting about 3 feet away from me, well, not during the COVID times, but when they're sitting right next to one another and they can have that debate and go back and forth and fix that and then do that in an iterative loop, by the time you
Yeah.
get to like version 10, you've got pretty good amount of you've got pretty good results, I think, and that's been very unique for us.
Hmm.
So those would be the couple of things I would offer you, and again, just it's you have to be patient with it. Um,
Yeah,
we certainly didn't have anything working probably in the first 60 days, but we quickly started seeing that ramp up, and there's a lot of it's transformation is about people's mindset and expectation, right? Um,
absolutely.
yeah, that's been a big change for us because we all think going into it, we're going to plug in a formula and we're going to be able to, you know, get the results. And when you don't get something that has a 95% confidence interval, you get disheartened, and that shouldn't be the case. Most of our models that we get value out of have an accuracy of anywhere from 40 to 60%, and that's we just iteratively improve that.
Right, right. But understanding that you've got a team that has that shared trust to
That's
kind of go back and forth and say, well, what are we trying to solve here? As different from I'm going to throw my data over the fence. Hopefully you'll do something with it. You'll throw something back to me. Hopefully it'll make sense.
right.
Um, but I want to lean into the aspect of that you're prototyping through multiple versions. So you don't expect what you build first to be right, that you actually have the time and the collaboration with the team to really think about that. Because I think that's where you'll also start to see a different outcome, where when you get to that V10, what you see possible is very different than what the team around the table thought when they were at V1. I'm curious for your reflections on that.
Oh, absolutely. I'll give you a very precise example. So when
Please.
when we first started using we call vibration data, right?
Mhm.
Um, the expectation was, and even I remember sitting there writing some of the Python script along with my colleagues, and our first expectation was that I'm going to plug this data in. It's so perfect. We've already had a failure to learn from. We're doing supervised learning. Perfect. I'm going to get a model, and the output of this is going to tell me that this is the type of failure, and you have this many days before you need to replace it next time. And that wasn't really the case. By around version 10, what we really learned is that the approach needed to be an unsupervised learning. Well, it's or unsupervised learning, that's type of model, right? Where it's simply telling you that this is an anomalous behavior, not necessarily that this is this particular type of failure. So what we do is we start with a subject matter expert
Yeah,
that tells you, hey, here are the things to learn off of. The data scientist comes and learn and builds a model, and the output of that is put back in the hands of the subject matter expert, where they say, oh, this is telling me that this is an anomalous behavior, and based on that, I can go and tell you that this is the problem. The alternative to that is that somebody, whether that's a subject matter expert, a vibe analyst, a data scientist, or an engineer, is looking at thousands and thousands of sensors on a day-to-day basis to figure out what's wrong, and
yeah.
really having that expectation that this is my worst case scenario, but if I take a different approach, I might be slightly less off, but it's a hell of a lot better than just churning through these many hundreds of billions of records of data. So that's been setting that expectation of what do you expect and how are you able to deliver value. And again, iteratively improved that. As I mentioned, we ran 6.5 in production for the first time. Today we run version 14, and it's still in test environment, but we keep making progress, and just again setting those expectations is key.
Yeah. So one last question in terms of that cross team collaboration for folks that are tuning in. Obviously, we all make mistakes. Can you share any learnings from mistakes or challenges for folks that are watching that might want to say, here's something to keep in mind that if I could rewind the clock, I would have approached differently?
Yeah,
Can I ask that to a statistician? I don't know.
I tell you, 9 or 10 things I do tend to be mistake. If not, I'll introduce you to my wife, um, and I mean that with all love in the world. So one of the first things that we did is try and load data from everywhere we could
Mm,
into a cloud, right? And back then we were still learning what is S3, and this thing called Redshift, and all these things. And coming from a ETL, more of the RDBMS type of world, we thought,
mhm.
well, let's think about how are we going to use the data? How do we want to create our star schema and
Yep.
fact and dimension tables? And let's get
Yep.
the ETL folks and put all of that together. And we did. And I'm not joking when I say it. We loaded entirety of many different RDBMSs into our data warehouse 11 times before realizing that we need to just completely stop um,
Mm.
doing this, this fixed structure on data, and just do, I mean, metaphorically, schema on read, such that you put all that data into the raw format
Yeah.
and let use cases dictate how and what you're going to need.
Yes.
So we joke about the fact that S3 is our best friend because we literally dump everything in there in Parquet files and in every other format, and make it really easy. We teach just about everybody on our team how to write SQL, right? And they most of the time they may not know, they just have different skill set, but we try and teach them such that when they need to use the data, and two people could be working on the same problem, but they're
Yeah.
going to look at data very differently because they're working on two models in their own approach, and they're going to come in and change how they need to look at the data. So if something is so rigid in a structure, and again, you can design that as best as you can, and then you're going to realize that, oh crap, I don't have this or that, and I wish I could pivot this data in this manner.
Yeah.
So and that becomes really tricky. So what we tend to do is we go into SageMaker and let people go manipulate that data as they need
Right.
against the raw data, come up with a solution, and then work backwards into
Yeah.
creating your own rigid structure if you must, because again, rigid structures have their own a whole host of benefits, right?
Yeah,
So,
absolutely. But again, like let the use case define what you should do. You don't want to over constrain to I may now only look at it in this particular way because suddenly you miss a potential of all the things that we can do over here. And you absolutely want to get that creativity and it's interesting because a lot of what you've said just so resonates with me when we think about smart city solutions or when we think about transit solutions. A lot of different folks need to come at this in very different ways, and
right.
if you force fit, this is the only way in which we're going to query this data, or this is how we've set it up, then you lose the potential of what another team really needs.
Mhm.
And you also lose the value of what's in there when you keep the data. So I'm a big fan of saying, yes, S3 can and should be our friend because you want to keep the data as raw as possible. So there are so many different things that you can do with it.
Absolutely. Yeah, and it's been, again, it's been transformative for us to think about things that way.
Yeah.
But it's the analogy that you learn best from your mistakes, and that I could not agree more with that.
Yeah, yeah. And again, it's an amazing journey when we think of all that's happened over the past few years with Georgia Pacific and how you're really able to innovate and transform. So, I wanted to really lean into in our last few minutes thinking more about data when we talk about, well, what might we be doing with data governance? What might we be doing to think about, well, what's the quality of data? Especially where you have the unique privilege, and I'll call it a privilege, of dealing with data that's coming from so many disparate places, right? A lot of folks like, oh, you can just put all this together. Like, hi, have you looked at the data? It didn't quite work that way. Um, like, how do you want to think about data governance or quality, especially when it is definitionally going to be disparate?
Yeah, so across our teams, we have a lot of folks that are focused on, and they're doing a phenomenal job, right? Focused on how do we create these policies, if you will, or these governance, the structure such that
Yeah.
a particular piece of equipment is called this, and every other system inherits that policy, right? Now that's phenomenal, right? And we should absolutely do that, but doing that backwards against all the different ERPs or all the different asset management solutions, it just it becomes quite cumbersome. And
Yeah.
of course, now we can't go and change all that history, or we can't wait till we clean all that up before we start a use case, because there's an impetus to move fast, right?
Right.
So what we tend to do is, well, first the realization was data is never going to be perfect, right?
Yes.
We can never have just about everything in the manner that we want, because one of the things we talked about earlier is use cases are going to be different, needs are going to be different, and it has to remain fluid.
Mm.
So, based on that, again, we do a lot of the schema and that we talked about. But purely, back on the quality of the data, we have a lot of models that we put into place that looks at, a particular stream of data, whether, that's a particular tag in a system or an IoT sensor, right? and
Yeah.
it does that. It does anomaly detection in real time. So, for example, if a particular sensor is used to giving data between 0 and 100 degrees, but all of a sudden is giving you 400 degrees, or all of a sudden, instead of it giving you an integer or a floating, it starts giving you a hexadecimal. Well,
Mm,
that's anomalous. Now you can constrict that by having, just about that particular field is defined as an integer or a floating point. What we tend to do is kind of keep that fluid, but add a anomaly detection on that. So the moment you
mhm.
get some data point that you're not used to seeing, that's
Yeah,
not necessarily defined by somebody, but more of a artificial intelligence against it, that
yeah,
gets flagged for somebody to go look at almost in real time. So that's one of the ways in how we get ahead of the data quality issues. But again, it's we can, everything so far, and this is um, and I don't know how else to best describe other than the fact that everything has been reactionary. Is like,
yeah.
oh, this is how data could get messed up. So how do
Mm,
we go and address it that way? Now we can again take the other approach of it has to be within this
yep,
parameter or this constraint, and if not, then I can't trust it. And trust me, we do a lot of that as well. But it's
right.
finding the right balance between whether that's the use case or what we're trying to solve. It just we work with it to figure out whatever we need to do and solve it at that point. But again, one of the things we talked about earlier is your best friend is just dump everything you get as is into S3, and then later on, if you realize that that hexadecimal was an error code, now you
Yeah,
can go and address that. you know
right.
if you put a constraint that says the moment I get anything but a floating point between 0 and 100, delete that. Well, right now, you'd be regretting that decision, right? So it's just compute and storage is, courtesy of the work that you guys do, it's relatively cheaper than where we were, right? Quite
Yeah.
much more affordable. So it's just easier for us to store as is and then and manipulate that later. So that's kind of been the driving force, again, not to get away from the governance question. There's a quite a bit of conversation to be had on that. But from our approach and how we drive value, that's been the kind of the philosophy, so to speak.
Yeah, yeah, and I deeply appreciate, the data is not going to be perfect.
Right.
What's good enough so we can move forward?
Right.
What closing comments have you got for folks, as key takeaways from your learnings, Roshan?
We talked about a couple of them, right? The first one being it's whether you build a model, whether you do any kind of, you look for data. 4 years ago, we used to, everything we did was it fit in Excel, right?
Yeah,
It was in 100,000 records. And, we used to think, man, yeah, we got big data, right? But we're in a much different place now. But you have to start somewhere. And,
yeah,
that's been our journey. Data is never going to be perfect, as we just talked about. And, you know, all things artificial intelligence, machine learning model, again, you got to start somewhere, and
yep.
it doesn't have to be perfect. Just because something has a an R squared or an accuracy of 30%, it's still pretty good to get started. And that's been our kind of our motto. Like, let's learn from it. We'll adjust and we'll move on. But time is money, and let's see what we can do with what we have.
Wonderful. Well, Roshan, thank you so much for this engaging discussion. And we will remember to keep learning, understand the data may not always be perfect, and to definitely utilize S3. I absolutely appreciate this. And thank you, everyone, for joining us for this edition of AWS On Air.
Thank you.